Good morning. Today we are going to be covering rational exponents. We have covered on the last chapter just exponents. Today are rational exponents. The rational comes from the word ratio, which means that we are going to be having fractions as the exponents. And we're going to be covering three of the basic properties of exponents, and we're going to apply those to rational exponents. Now, the first one is the product of powers property. If we have two terms multiplying and they have the same base, we can just go ahead and add the exponents. So in this case, we have 9 to the 1/3 multiplied by 9 to the 2/3. If you notice they have the same base, we're going to be adding the exponents. So we just have 9. They have the same denominator, so we can just add 1 plus 2 is 3, and the denominator is kept. So we just have 9 to the 1 power, or just 9. When the exponent's outside, it's a power of powers property, we are going to be multiplying. In this case, we have 27 to the 1/2, and then we have to the 4/3. We are going to multiply the exponents. The base will stay the same, 27. 1 times 4 is 4, 2 times 3 is 6. Remember, when you multiply, you just multiply across. Now, let's go and reduce our exponents. So I'll be 27 and divide by 2, so I'll be 2 over 3. Now, remember on the last section, we are able to simplify this, so we're going to rewrite it as a radical 27. This denominator for the exponent is the root, and then the 2 is the exponent. Now, the cube root of 27, I'm looking for a number that multiplies by itself 3 times, gives me 27. That'll be 3, and I still have my square, and 3 squared is equal to 9. So my final answer will be 9 as well. For the quotient of powers property, if we are two terms and they have the same base, we can subtract the exponents. In this case, they have the same base, 125, the top and the bottom. We need to subtract. Remember, to subtract, we need to have the same denominator. They do have the same denominator, so we can just have 125. 2/3 minus 1/3 will be 1/3. 2 minus 1 is 1. The denominator stays the same. And we are going to be able to rewrite it. Now at this point, you should be able to think that this is the cube root of 125, which is equal to 5. So I want you guys to start thinking that 125 automatically to the 1/3 is equal to 5. Let's go and start with example number 1. On example number 1, I need to be able to simplify. They have the same base, so I can just go ahead and add the exponents. So it'll be 3. The base stays the same. Do not multiply 3 times 3. The base will stay the same. We are going to go ahead and add the exponents. So in order to add, they have to have the same denominator. They do, so we can just add. 5 plus 1 will give me 6. Denominator stays the same. I'm going to simplify, so it gives me 3 to the 2nd power. And that is equal to 9. For letter B, when the exponent is outside the parentheses, we're going to use the power of powers property, which is the second one. We're going to multiply. That'll be 27 stays the same. When you multiply, you don't need to have the same denominator. We can just multiply across. 2 times 1 will give me 2. 3 times 2 will give me 6. I'm going to reduce my fraction. So divide by 2 gives me 1 over 3. Same thing as mentioned right now. 27 to the 1/3 is the same thing as the cube root of 27, which is equal to 3. For letter C, when they're dividing, if they have the same base, we can go ahead and subtract the exponents. So we're using the quotient of powers property. 3/5 minus 2/5. When we subtract, we need to have the same denominator. In this case, they already do. So this will be 1. 3 minus 2 is 1 over 5. I want you guys to think as 32 to the 1/5 as the cube root or the fifth root of 32. So I'm looking for a number that multiplies by itself 5 times, gives me 32, which is 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Now letter D is a little more complex. We have an exponent outside, so I'm just going to multiply by each of the exponents that are inside the numerator and the denominator. So we have 5, 1/2 times 2. In order to multiply a whole number by a fraction, I'm going to place it over 1. Positive times negative is negative. 2 times 1 is 2. 1 times 2 is 2. I'm going to do the same thing with the denominator. 8. In order to multiply a whole number by a fraction, I'm going to place it over 1. Positive times negative is negative. 2 times 1 is 2. 1 times 2 is 2. I'm going to reduce my fraction for the exponent. So it'll be 2 divided by 2 is negative 1. 2 divided by 2 is negative 1. When I have a negative exponent, to make it positive, I switch it to the bottom. If it's a negative exponent on the bottom, I switch it to the top. So this is the case where you have to switch both of them because they both are negative. So I have 8 over 5. Notice that this one becomes a positive, but I no longer need the exponent. I don't need to place a 1. So my answer will be just 8/5. Let's continue with example number 2. On example number 2, we start to have variables. And they are multiplied, x to the 1/3 multiplied by x to the 1/5. Because they're multiplying, I'm going to go ahead and add the exponents. The base will stay the same. I need to add 1/3 plus 1/5. They need to have the same denominators, and they don't. So I'm going to make them the same denominators. I'm going to have the same denominator will be 15. Multiply the left by 5. The right by 3. That will give me 5 over 15 plus 3 over 15, which is equal to 8 over 15. 5 plus 3 is 8. The denominator is kept the same. So that will be the exponent. We cannot reduce it, so we just leave it as is. For letter B, the exponents outside the parentheses, so we're going to multiply. Don't forget to place the exponent for the 8. Automatically there's a 1, so I want you guys to automatically place your exponent if you're going to multiply. 1 times 1/3 will give me 8 to the 1/3. To multiply a whole number by a fraction, I'm going to place over 1. So I'll be y. 12 times 1 is 12. 1 times 3 is 3. I'm going to simplify it. 8 to the 1/3 is equal to 2. Remember, that's the cube root of 8. Y to the 12 over 3. 12 over 3 is equal to 4. For letter C, when they're dividing, I'm going to go ahead and subtract my exponents. They don't have the same denominator. When I subtract or add, I need to have the same denominator. So let me write them down underneath. I know that the x will stay there. That'll be 3 over 7 minus 1/3. The common denominator will be 21. I'm going to multiply by 3 on the left hand side. I'm going to multiply by 7 on the right hand side. So that will give me 9 over 21 minus 7 over 21 as well. 9 minus 7 is 2. The denominator is kept the same. Remember, I multiply 3 times 7. That's 21. So my exponent will be 2 over 21. We basically just subtracted the exponents. Letter D. I'm going to reduce my fraction first. They don't have an exponent, so I can just go and reduce it like any normal fraction. So it'll be 1 over 3. Let's go and deal with the x's first. I'm going to subtract the exponent because they're divided. So 3/4 minus 1/4. 3 minus 2. 3 minus 1 is 2. Will be x 2/4. There's only one y, so let's not forget about the y. Then for the z's, I'm not going to bring negative exponents, we bring them down. So that'll be z to the 1/3. I'm not going to add the exponents because now they're multiplying, so it'll be z. 2 plus 1 is 3, and denominator is 3. Remember, they have the same denominator, so we were fine. I'm going to go and simplify. This is x to the 1/2. I no longer need the 1. I'm not going to place the 1 in there, so it'll be just x to the 1/2 y 3. Z will be 3 divided by 3 is 1, or just z. And that's it for example number 2.